He helped build the car company that forced every automaker on Earth to go electric. Then, at the absolute peak, he walked away from Tesla. Not to start another car company. Not to build a better battery. J.B. Straubel left to dig through the one thing the entire electric revolution depends on, but nobody wanted to touch. Dead batteries. And while the world is racing to mine more lithium, he bet his entire legacy on a number that changes everything. 95%. Today, Redwood Materials is the largest battery recycler in North America. But Straubel didn't build it to save the planet. He built it because he saw a supply chain that China already controls, a country that imports almost all its critical minerals, and a moment coming when every electric vehicle battery would need to be replaced, all at once. And he knew it would arrive faster than anyone in Detroit wanted to admit. J.B. Straubel was Tesla employee number 5. He joined in 2004, 2 years before Elon Musk became CEO, and he stayed long enough to see the company survive near bankruptcy, launch the Model S, and ignite a global electric revolution. His name is on more than a dozen patents that made Tesla's batteries safer, cheaper, and more powerful than anything Detroit had ever seen. But sometime around 2015, while the rest of the industry was counting Model 3 pre-orders, Straubel was running a different kind of math. He was calculating how much lithium, cobalt, and nickel the world would need if every automaker actually went electric. The numbers were staggering, and the sourcing map looked even worse. According to Bloomberg NF, China controls 70% of the planet's lithium refining capacity and as much as 95% of production for other crucial battery materials. The United States imports nearly all its cobalt from the Democratic Republic of Congo, its nickel from Russia and Indonesia, its lithium from Australia and South America. The entire American electric vehicle dream runs on a supply chain that stretches through unstable regions and adversarial nations through a single choke point called China. Straubel saw what that meant. Every battery pack sold in the US was shipping its most valuable minerals out of American control permanently. And when those packs died, they became toxic waste shipped to landfills or sent overseas to be dismantled by hand. So in 2017, while still Tesla's chief technology officer, he quietly founded a startup called Redwood Materials in a dusty corner of Nevada. His plan was simple to describe and almost impossible to execute. Take dead batteries, recover every critical mineral inside, and turn them straight back into new batteries. A closed loop. No mining. No foreign dependence. But building North America's first battery recycling empire meant solving a problem no one had cracked at scale. The chemistry was brutal, and Straubel was about to learn that the hardest part wouldn't be the science. It would be convincing an entire industry that the solution he was chasing wasn't a science project. It was a survival plan. By 2019, he was ready to prove it. Straubel stepped down as Tesla's chief technology officer, saying goodbye to the company he had spent 15 years building. The reaction from Silicon Valley was disbelief. Why would anyone walk away from the most valuable electric car company on Earth to dig through garbage? But Straubel didn't see garbage. He saw a trillion-dollar supply chain that America had completely outsourced. Here's the problem he was trying to solve. A single electric vehicle battery pack contains hundreds of pounds of lithium, cobalt, nickel, and copper. Mining those minerals from the ground is expensive, environmentally destructive, and increasingly controlled by China. But inside a dead battery, those same minerals are already refined, already purified, and sitting in a casing that someone has already paid billions to manufacture. Straubel's insight was so simple it almost sounded stupid. Instead of digging new holes in the ground, dig into the battery graveyard that was about to arrive. The chemistry, however, was not simple at all. Redwood Materials had to invent a system that could take a 3,000-pound Tesla battery pack, shred it down to black powder, and then extract lithium, cobalt, and nickel at purities high enough to go straight back into a brand new battery. The company developed a proprietary hydrometallurgy process that combines mechanical shredding, chemical extraction, and high-temperature purification. By 2023, they announced a number that made the entire mining industry take notice. Redwood was recovering 95% of the lithium from scrap battery materials. Not 90, not 93, 95%. That meant for every 20 pounds of lithium in a dead pack, 19 pounds came back out ready for reuse. But even with that breakthrough, Straubel faced a deeper problem. There were not enough dead EV batteries yet to feed his factory. Most electric cars were still on the road. So Redwood pivoted to what was already piling up: consumer electronics, old cell phones, laptops, and power tools. But that supply was limited too. So the company did something unexpected. When they started receiving packs that were too degraded for a car but still holding a charge, they didn't shred them. They tested them, repackaged them, and began building stationary energy storage systems. By late 2024, Redwood had accumulated over a gigawatt-hour of reusable batteries, enough to power 12,000 homes. A second stream of value emerged from what was supposed to be waste. The United States government saw what was happening. In 2023, the Department of Energy awarded Redwood a $2 billion loan commitment to expand operations. The message was unmistakable. Washington now viewed battery recycling as a matter of national security. Without it, America's entire electric vehicle transition would remain dependent on foreign refineries and vulnerable to supply shocks. With it, the country could build a closed loop that kept critical minerals inside American borders permanently. Then came the flood of commercial deals. Volkswagen signed on. Panasonic signed on. Toyota and Lyft both struck agreements to send their end-of-life batteries to Nevada. The company broke ground on a $3.5 billion campus in South Carolina, the largest economic development project in that state's history. By October 2025, Redwood Materials had raised another $350 million at a valuation above $6 billion, bringing total funding to over $2.2 billion. Revenue hit $200 million, and the Nevada campus was processing more than 60,000 metric tons of materials annually. But here's the part nobody talks about. Even with all that momentum, Redwood was still only scratching the surface. The real wave hasn't arrived yet. The first mass-market electric vehicles sold a decade ago are just now reaching the end of their useful lives. Over the next 10 years, millions of battery packs will need disposal, and the total volume of recyclable material will be nearly 10 times greater than what the entire North American market processes today. If Redwood can capture that tsunami, it won't just be the largest battery recycler in North America. It will become a domestic mining operation producing critical minerals at a scale that directly challenges China's dominance over the global supply chain. But there is a catch. And it's the one thing Straubel cannot control. The same geopolitical cost advantage that let China corner the refining market is now being trained on recycling. And if Redwood fails to reach the scale it needs before Beijing turns its attention to this new front, the entire gamble, the walkout from Tesla, the billions in investment, the survival plan, could collapse into a cautionary tale. This is the race that nobody knows is happening, and the finish line is already in sight. That pressure started showing in ways the press releases didn't mention. In November 2025, Redwood Materials fired dozens of employees across multiple departments. The company confirmed the layoffs but framed them as a realignment, a necessary step to focus on its core manufacturing goals. But inside the industry, the move sent a different signal. Even with $2 billion in the bank, even with government backing and deals with every major automaker, Redwood was burning cash faster than it could bring in revenue. Building a recycling empire from scratch is not a software problem. It is a heavy industrial problem. And heavy industry punishes optimism. Then came the announcement that reframed the entire bet. Redwood wasn't just going to recycle batteries. It was going to manufacture cathode active material on American soil for the first time at commercial scale. The cathode is the single most expensive component in a lithium-ion battery, and as of 2024, almost all of it was made in China. Straubel wasn't entering the recycling business. He was entering the refining and chemical manufacturing business, competing head-on with the industrial infrastructure that Beijing spent 2 decades and hundreds of billions of dollars building. Redwood's South Carolina campus, the one that broke ground as a recycling facility, was now slated to produce enough cathode material to build more than 1.3 million electric vehicles per year by 2028. That output would eclipse anything currently manufactured in North America. This was the end game. Straubel had looked at the map and realized that recycling alone would never close the loop. You could collect every dead battery in America, but if you still had to ship the black powder to China for final processing, you hadn't solved the dependency problem. You had just added an extra step. So Redwood designed its facilities to do both: shred the old batteries and synthesize the new cathode powder in the same complex, cutting out overseas refineries entirely. The chemistry was brutal. The capital requirements were staggering. But if it worked, the United States would have a domestic supply of the most strategically vital material in the electric age, produced not from a mine in the Congo, but from the junked electronics already sitting in American garages. But here is what makes this race so dangerous. China saw the same future and moved first. While Redwood was still scaling its pilot plant, Chinese firms were already building mega recycling campuses in Zhejiang and Guangdong, backed by state subsidies and access to the world's largest pool of retired electric vehicles. The cost structures were incomparable. Chinese recyclers could operate on thinner margins, pay lower wages, and benefit from a regulatory system that fast-tracked industrial projects in months instead of years. Redwood had to fight for every permit, every zoning variance, every environmental review. Its South Carolina facility took 3 years from announcement to initial operations. In China, a comparable plant could break ground and start production in 18 months. The math becomes simple. If the flood of American battery retirements arrives faster than Redwood can scale, the excess volume will flow to the lowest cost processor. That means China. And once those critical minerals leave American shores in a shipping container, they will come back as finished cathodes, sold at a markup to the same automakers that Redwood is trying to supply. The loop won't close. It will just change direction. Straubel understood this from the beginning. In a 2024 interview, he said something that sounded less like a business plan and more like a warning. "We are going at breakneck speed," he admitted. "But we need to do a whole lot more. It's a damn hard thing to do." He was not exaggerating. By the end of 2025, Redwood had proven the technology, secured the funding, and lined up the customers. But it had not yet proven that a made-in-America battery circular economy could survive a price war with the most aggressive industrial machine in history. What happens next will determine whether the United States has a genuine alternative to China's stranglehold on electric vehicle materials, or whether it simply builds a fancier conveyor belt feeding the same dependence. And the answer rides on a single number that most people still do not understand. 95% recovery is impressive. But a 95% closed loop that costs twice as much as virgin material is not a business. It is a charity. The question now is whether Straubel can drive costs down fast enough to turn his survival plan into a survival reality. And the clock is ticking louder than anyone in Washington wants to hear. By the end of 2025, Redwood Materials recycled 20 gigawatt-hours of lithium-ion batteries in a single year, enough to represent 250,000 electric vehicles. Its Nevada campus alone produced more than 60,000 metric tons of critical materials, making it one of the most important sources of lithium, cobalt, and nickel inside the United States, and none of it came from a mine. The South Carolina facility, the largest economic development project in that state's history, started initial operations in November and immediately added another 20,000 metric tons of annual processing capacity. This was no longer a pilot plant. It was an industrial machine. But the real payoff of Straubel's bet is not measured in tons of black powder. It is measured in what that powder becomes. Inside the same complex that shreds dead batteries, Redwood is now building cathode active material, the most expensive component in any electric vehicle battery, at commercial scale. This is the part that China has dominated for a decade. By 2028, Redwood plans to produce enough cathode material in South Carolina to manufacture 1.3 million electric cars per year. Not from minerals shipped from the Congo. Not from lithium refined in Guangzhou. From the phones in your kitchen drawer, the laptop you threw away 5 years ago, and the first generation of Tesla Model S packs that ended their useful lives. The loop is closing. The implications are bigger than most people realize. A fully operational closed-loop battery supply chain means that when you buy an electric vehicle in 2030, the minerals in that battery might have already powered 2 previous cars and a data center in between. The Department of Energy's $2 billion loan commitment was not just a subsidy. It was a recognition that battery recycling is now a pillar of national energy security. Without it, every electric vehicle sold in America is just a rental on minerals that eventually leave the country. With it, the United States builds a permanent domestic reserve that grows every time a battery dies. But here is the detail that almost no one noticed. While the headlines focused on cathodes and recycling rates, Redwood was quietly creating a third business that solves a different problem entirely. When the company received tens of thousands of used EV batteries that still held 80% of their original capacity, Straubel refused to shred them. Instead, his team tested, repackaged, and began building microgrid energy storage systems for data centers. By the end of 2024, Redwood held over 1 gigawatt-hour of reusable batteries in inventory. That is enough to power 12,500 homes, but its real destination was the massive server farms now training artificial intelligence. The same revolution that demands more computing power than the grid can deliver will be supported by the same batteries that once drove the electric revolution. The 2 megatrends of the 21st century, electrification and AI, are converging inside Redwood's warehouses, and the company that controls the battery afterlife controls the fuel for both. Straubel saw this before almost anyone else in the industry. In early 2025, he told an interviewer that he remembered the feeling of holding the flag for electric vehicles when the rest of the world doubted. Now, he said, he experiences déjà vu with battery recycling. The same dismissal, the same urgency, the same slow awakening by legacy players. But the window to win is not unlimited. China's own recycling megafactories are scaling fast, and the cost gap remains real. For Redwood to succeed, it must prove that a domestic closed loop can compete not just on technology, but on price. The numbers are trending in the right direction, but the battle is far from over. The man who helped build Tesla from almost nothing is now building the industrial backbone that could make the entire electric vehicle transition sustainable. And if he succeeds, the United States will not only produce its own electric cars, it will produce its own electric materials forever. But that forever depends on a race that is still unfolding. Redwood Materials is proving that a closed-loop battery economy is possible. The question is whether America has the will to protect it from the same forces that shipped away its manufacturing, its steel, and its solar panels. Because if this works, it won't just be about recycling. It will be about a fundamental shift in who controls the energy of the future. And the most interesting part? The same technology that could secure America's energy future might also power the AI data centers that are reshaping everything else. The battery recycling revolution isn't just about cars. It's about the entire infrastructure of the next 50 years. If this kind of story makes sense to you, if you believe the real infrastructure that powers our lives is built by people most of the world ignores, then I've got something for you. The link in the first pinned comment has a special offer just for this community. And I want to hear from you. Do you think battery recycling can replace mining? Or is it just another dependency chain? Drop your answer in the comments below. I read them all. Hit subscribe, and I'll see you in the next one.